hello everybody, welcome back. So today we'll be talking about the next basic derivative rule, which is the sum and difference rules. So this is part 3 of the basic differentiation rules. So let's say we want to take the derivative of a function f of x plus another function g of x. Well, we know that the derivative of a function is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over, or minus f of x all over delta x. Now, let me actually say that my function f of x is equal to g of x plus h of x. So now, what we do is we take what's in here, the x plus delta x, and plug it in for x in our function f of x. But our function f of x is g of x plus h of x. So what we do is we plug this in for g of x and h of x. So let's say we had f of 3, that would be equal to g of 3 plus h of 3. So f of x plus delta x is equal to g of x plus delta x plus h of x plus delta x. So we end up with a limit as delta x approaches 0 of g of x plus delta x plus h of x plus delta x minus the function f of x, which is g of x plus h of x over delta x. So this is the limit as delta x approaches 0 of g of x plus delta x plus h of x plus delta x minus, now we distribute the negative sign out, we get minus g of x minus h of x over delta x. Now we compare this minus g of x with this g of x, compare this h of x plus delta x with this minus h of x. This gives us the limit as delta x approaches 0, g of x plus delta x minus g of x over delta x plus f of x plus delta x, or h of x, sorry, not f of x, h of x plus delta x minus h of x over delta x. Where I've set it so that we can split the numerator when there's addition and subtraction. If we have a plus b over c, we can split this into a over c plus b over c. Now we know that the limit of a sum is equal to the sum of the limits. So we know that the limit as delta x approaches 0 of g of x plus delta x minus g of x over delta x. This is g prime of x plus the limit of h of x plus delta x minus h of x over delta x as delta x approaches 0 is just h prime of x. So what this tells us is that the derivative of the sum of functions is the sum of the derivatives of those functions. So the sum and difference rules, and let's say you had g of x minus h of x instead of g of x plus h of x. Well, you could say that this is g of x plus negative h of x. Then it would still be a sum of two functions. Or if you wanted to, you could prove that it works for g of x minus h of x, which is just g of x plus negative h of x. But if you want to prove that, I'll leave that as an exercise for the viewer. But we can see from that the derivative of two functions, f of x plus g of x, is equal to the derivative of f of x plus the derivative of g of x. Or, to write it in a cleaner manner, f prime, or f, the derivative of f of x plus g of x is equal to f prime of x plus g prime of x. And we said that this works for g of x minus h of x as well, or f of x minus g of x as well. So we can take this and make it plus or minus. So this is the rule. The derivative of f of x plus or minus g of x is equal to the derivative of f of x plus or minus the derivative of g of x. So let's do an example. Say f of x is equal to x squared plus 2x. This here is a fairly standard polynomial. If you want to take the derivative of this, f prime of x ddx of x squared plus 2x. Now we know from the sum and difference rule that the derivative of x squared plus 2x is equal to the derivative of x squared plus the derivative of 2x. For this first one, from the power rule, we know that this becomes 2, if we multiply the exponent by the coefficient, times x to the 2 minus 1, which is equal to 2x. And this part here becomes 2 times the derivative of x, which is equal to 2 times 1, which is equal to 2. So adding these together, we get that f prime of x is equal to 2x plus 2. So just by using that basic rule, we were able to turn this function, x squared plus 2x, into something that was in two components, x squared and 2x, that were easily differentiable. Now let's say I had a function f of x equal to 3x squared plus 7x plus 8. So this one's a little more complicated, but it follows the same general process. So f prime of x is equal to the derivative of 3x 3x squared plus 7x plus 8, which is equal to the derivative of 3x squared plus the derivative of 7x plus the derivative of it. Now, if we look at each of these cases separately, the derivative of 3x squared, multiply the coefficient by the exponent, 3 times 2 gives us 6, x, exponent minus 1, so 6x to the 2 minus 1, which is equal to 6x. The derivative of 7x, we know is 7 times the derivative of x, which is equal to 7. And anytime you have the derivative of c times x, you can, instead of writing down, you move the c out from, then take the derivative of x, which is 1, you can just say that this is equal to c. So the derivative of 7x would be equal to 7. And then for this one, the derivative of 8, this is the derivative of constant, which is 0. So we end up with f prime of x being equal to 6x plus 7. So that is the sum and difference rules, and that'll conclude this episode. So again, if you have any questions, leave them down in the comments below. Thank you for watching. I hope you have a great rest of your day.